Hello, everyone. Welcome to our webinar. Let's wait for one more minute to get everyone in, and we'll start. In the meantime, feel free to ask us questions in the Q&A. On the bottom, you have a button that says Q&A. And also, if you want to introduce yourself in the chat, you're welcome to do that as well. We'll start soon.
The safest method to transfer data is put it on a disk, right?
Oh, a floppy drive.
Yeah, and send it.
Amazing. It's the History Channel.
Yeah, exactly. The
Nice.
museum.
How to encrypt your floppy disk. That's the
Yeah.
topic today.
Wow. Very nice.
Yeah.
Let's see. So I think we're good, right? It's 2 minutes after the hour. We should be able to start. So hello, everyone. Welcome to our webinar. My name is Noam Dror, and we are here going to talk about cloud and sensitive data, risk and solution with our distinguished panel here. So first, let's do introduction to our speakers. The first is Kevin Keller of Snowflake. Do you want to introduce yourself, Kevin?
Yeah, sure. So I'm a security field CTO at Snowflake. In the security team, I usually talk about security controls and which security controls Snowflake has, but that often goes into a wider discussion of general industry best practices, general industry security patterns, and how you properly integrate data. So even though I work for Snowflake, what we are going to discuss it doesn't only pertain now to Snowflake, but so I have a lot of discussion in general how to safeguard data, talking about, of course, GDPR and all of these things, PRI sensitive data. Also a lot about how to encrypt this data. So I work with over 200 customers in Europe right now. So I've seen a lot of use cases and a lot of things. So I'm happy to share all of this experience today. And I'm really excited to see you guys again and be here with Ellen, who has also such a wealth of experience. So maybe you can.
Yeah, that sounds good. It sounds like it's going to be an interesting webinar. So let's go to Alon Rosenthal, SecuPi. Tell us a little bit about yourself.
Thank you, Kevin. Yeah, my name is Alon Rosenthal, co-founder, CEO of SecuPi. Been doing data privacy security for the last 15 years. I invented this notion of dynamic masking before Snowflake. They created that in my first company, which later was acquired by Informatica. And left Informatica because I've seen the over-fragmented of the market, where really there's a requirement to provide one overarching platform, from the monitoring to the access control, from the masking to the encryption, from the role-based to the attribute-based access control. That's what really notable customers need. And today we are serving over 100 global 2,000 customers. For example, in Europe, we can mention Swisscom and Vodafone and few Swiss banks, many insurance customers, retail, etc. So also been doing like having a lot of data privacy, data security, having seen also how the market evolves through the GDPR, from the early days of GDPR, and when everybody was looking for some kind of what we call the paper shield, right? Let's get some lawyers and be able to get it off our back, to moving from the paper shield to the IT shield, right? To actually doing something about it, and to restrict access on a need-to-know basis, which is a really major theme for all of our work, right? This notion of access control and really access on a need-to-know basis. So happy to be here and to talk about those really critical topics.
Makes sense. And it's all started in paper, right? That's why we have files and folders It started anywhere. Anyway, so today we're going to talk about cloud and sensitive data risks and solutions. The main reason is that more and more analytics are moving to the cloud. And as you want to do more analytics and get more insights, you get more and more access to data and more sensitive data. And therefore, there are different solutions to protect that data, right? We will go over attribute-based access control, fine-grained authorization, and format-preserving encryption, and physical and logical deletions, and different compliances, of course, for GDPR, for privacy. So we'll go over that. So maybe the first question for you guys is, how can fine-grained access control, that's one of the the solutions we're going to talk about, can strengthen data security in cloud analytics, right? What are the practical benefits to organizations? So who wants to take that first? How about Alon? You'll start.
Okay, great. Yeah, especially with the GDPR, as we're talking now and both of us are now based in and see a lot of European customers. GDPR included a new dimension in the old ABAC, right? It all started with roles, right? And that's where everything starts. But then GDPR came, and GDPR introduced another attribute called consent. And then once consent was required, right, then we need to allow access not only based on the role of the user, but based on the customer consent. And then it became even trickier, because after GDPR, CCPA, CPRA started LGPD, PDPA, PDPB, right, data cross-border controls. So also the citizenship, so also the location of the user, as well as the citizenship of the customer came into consideration. So all of those different attributes started to pop up, and once a data set would be lifted to Snowflake, right, then those multiple attributes have to be taken into consideration when providing access. Yeah. And that's where things have become more complicated. So once every access to sensitive data needs to take all of those attributes into consideration, right, then when you look at a request, a report that queries the customer table, right, how can we add those considerations or those attributes, or in the database, those columns, into consideration? Should we put all of those columns into the customer table, or can we still keep our independent access to data while pulling attributes from multiple sources? First from a source such as Snowflake, like for example, an attribute table in Snowflake, but then also attributes coming from other sources like an operational system, or maybe Salesforce, right, or Workday for the hierarchy of the user, right? Yeah. So both the abundance of attributes are required today to provision access, as well as taking all of them into consideration in real time when the user runs a request. So all of these come to fruition, and we need to provide a technology to address all of those, both statically, dynamically, to provision those attributes and to allow access in a transparent way, because end users just want to crunch the data. So that's the challenges that we've seen, and through the evolution of the SecuPi platform, we've been able to create a processor that will be able to pull those attributes based on different time, based on different sources, operational, analytical sources that are in the same table, or distributed even within the Snowflake schema, and being able to pull those attributes into the execution of a query to ensure that access to the results that are performed on a need-to-know basis.
Yeah. Talking about that, I had a call with a customer today that told me they want the users to have the only access to their own data, right? And they want the users to allow other people to get access to their data, right? So the challenge in Snowflake and any other environment is, one, you don't always have all the users, right? If you have a company with hundreds of thousands of employees, not necessarily you're going to provision all of those users into every database. That's one. And then provision the access controls separately. The second problem is when you do role-based access control, it's reactive. You need to predefine everything. Two, it's centrally managed, so an administrator needs to manage that. It's not really easy to delegate authority to do that. So when you talk about dynamic authorization, and attribute-based access control is dynamic authorization, you can delegate the authority to do specific attributes or tags to the data to allow access dynamically to people that individual users would like to add. So we talked about that. I told them, yeah, just upload the data. We will encrypt it for you, right? You are the only one who has access to the data unless you add a tag to the data saying, who do you want to add that, right? So if you have a tag of a group or a tag of a department or a tag of a region or any kind of a tag, just add a tag to the table you want to add access to, and they will be able to see that data for you, right? But still, the user controls everything without the need to populate the central database with hundreds of thousands of users, right? Because that's an administration overhead. So dynamic authorization, attribute-based access control, policy-based access control is really important in that kind of situation. I had a call today, so what you just said made a lot of sense to me right now.
Yeah.
Kevin, what do you think about that topic, about dynamic authorization?
Yeah, absolutely. I get a lot of questions around this. So the most classic question in practical terms that I get is somebody logs in to Snowflake from a different location, and now they are not supposed to see some data. For example, I usually log in from Germany, and maybe I work in the HR department in Germany, so I can see German PII data, but I'm not supposed to see French PII data. And of course, you can say also Snowflake, but other tools as well have the ability with role-based access and masking to help with that. But if your requirements are more stringent, if they say, yes, role-based access, somebody can override this somehow as an account admin, we have to monitor this. We need to have policies that make it technically impossible for somebody that sits in Germany to see French PII data. Then these policies come really nice, because then you don't have always the same access no matter where you are, right? The context, really what this does is providing context around why the user is logging in, where the user is logging in from, what is the intention of the user based on the context, and then based on that, decisions should be dynamic. The access should be given dynamic and not always shouldn't be always the same. So yeah.
What you just said reminded me, when I work with aerospace and defense kind of companies, they need to comply with export control regulations, and export control regulations really forces you to understand where the user is actually right now in the world, regardless of where they live. You need to know their citizenship, which is an attribute, but you need to know their physical location. Are they in the country they're citizens of, or are they outside of that country? And if they're outside of that country, that is considered an export of data. And if you're in violation of an export control regulation, that's a hefty fine. So that's another perfect example of where dynamic authorization and policy-based access control comes into play.
Yeah.
Looks like you have some visual for us.
Yeah. So this is some kind of how we design it all. Because when you talk about different attributes, right, you need some kind of a centralized processor to be able to pull attributes in a performant way. Right? You don't want to query your Active Directory for every query going to Snowflake. Right? You want to do it in a manner that will keep those sources performant, but still get the relevant attributes from all of them. Right? So whether this is the identity attributes or grouping or location attributes from Okta or even HR system to get the user hierarchy, right? Sometimes we see ABAC not only linear but also hierarchy. For example, you have different type of data, critical data, sensitive data, public data. People who are allowed access to critical data should be able also to see public data, but not the other way around. Right? So sometimes you need to apply the filters based on a hierarchy. Sometimes they are really can be done on a linear basis, but also pulling different data relevant attributes such as the sensitivity of the data. And this can come from also other type of sources like Colibra and deletion. So all of those attributes somehow needs to be populated into the different enforcement points that we would like to distribute in order to apply the ABAC at scale across everywhere sensitive data resides, right? The Snowflake, but also to other SQL stores as well as to MongoDB, right? DynamoDB, or CosmoDB, right? Data is everywhere, and the centralized pane of glass that needs to take all of those attributes and basically cache them, push them down to different data silos so they can be enforced. Right? Because the worst thing that can happen is that you allow certain type of access in Snowflake, but then break this entire access control when data is in MongoDB or in Oracle or in Postgres, right? The consistency and the ability to audit to ensure that those regulations are intact and that the ABAC, this dynamic authorization, is enforced across the entire cloud is really required. We hear now a lot about DORA, this new financial regulation in Europe. Also, the regulators that are imposing more and more restriction to the data access.
And second cloud in France is also very
Second cloud in France, right?
Yeah.
Right.
Sorry,
Alan. And then, of course, when you look at the entire stack, right, we have other types of enforcements that would really be able to embrace the ABAC and push it down to everything and everywhere. Even on DB2s, we have customers that use also the same level of ABAC, even on WebSphere applications running on mainframe in large insurance customers that have, claim application, policy application, WebSphere running still on mainframe, to, of course, data application running on Snowflake and everything in between. So the externalization of the ABAC, the policies, and the ability to enforce them across every silo of sensitive data, that's where the regulation is heading into, and that's where we as an industry needs to suffice with a broad technology stack.
So let me ask you a tougher question then. So it's all nice what you're saying. You can get attributes from different things, and you have a dedicated processor. But at the end, when you're talking about a database or a data platform, it's usually service accounts.
Right.
So how do you deal with that? You want to apply the policies you're talking about to the original user? How do you address that?
Sure, that's why we provide 5 different enforcement technologies. Right? The question of the application user is something that has been one of the secrets that everybody know and nobody does anything about. Right? It's one of those secrets that we as ex-DBAs, right, and people who are day-to-day working with databases, we always have seen those service accounts as a huge blind spot, and nobody has solved that challenge in the industry. And that's why we have extended the enforcement points also to be able to embed themselves into even application. So we have agents that can be deployed on a Java application, so we can track the user through the entire application stack, right? So if this is an application, it can be also Starburst and the Nodo, right? It can be also those data mesh platforms. If I'm sitting on Snowflake, right, I would only see the Nodo or the Starburst service account querying the data source. So how can I apply ABAC if my attributes are in Snowflake, but the user is not defined and not apparent in Snowflake? Yeah. And that's why we are complementing that with an agent that can sit with 0 code changes on my Java application, .NET application, Spring Boot application, right? As well as on the Nodo, the Starburst, the Dremio, Trino, and other data orchestration layers. And that's also for the Snowflake data applications, as well as native cloud applications running on Lambda and Azure functions. Similar challenges there. Right?
So good. You're saying there is an ability to know the actual identity and apply the rules according to the actual identity, right? Of course, I'm guessing that's also connected to privilege access management and how an individual user can use a privilege account against a database, right?
Sure. And you see the richness of attributes, right? On the application, we know even the client IP. We know the operation system user. We know the application role. Right? All of those attributes are getting lost once we try to apply those attributes within a data store, such as Snowflake. Right? And that's the definition. Right?
Okay. So we talked about dynamic authorization. Let's talk a little bit about encryption, right? So encryption is being deployed to safeguard sensitive data, right? And maintain regulatory compliance. You know, what techniques are available out there? So maybe Kevin, you'll take that. What techniques are available for encryption out there for cloud-based applications and definitely for Snowflake specifically?
Right. Yeah, so first and foremost, I of course I have to say that not that this is confusing, right? If we talk about Snowflake now, that all the data is always, all customer data, right, is always encrypted at rest and in transit using a NIST compliant key hierarchy that's dedicated to account, and customer can also bring their own key. But the thing about this is, and it's, you know, it's highly secure and all. And there's also key rotation. So there's a lot going on out of the box. It's just part of the product. But the thing is that in this scenario, you still, and this is the nature of the cloud, right? This is not only for Snowflake. We are managing the key material to the most extent. And then there's always a certain element of trust that you have to bring there. And that's also fine. This is also like just like that. So there's this trade-off, right, between complete control over your data, hard complete control in your on-premise world, and the flexibility and the benefits of the cloud, where there's always, you know, cloud providers have best-in-class security, just as Snowflake, but there's always a little bit of, you know, not everything is controlled by you anymore, right? You have to trust. And then what if you don't have this luxury where you do trust already, but you have a policy that says trust is not enough. We need some kind of on-premise control over our data, meaning that at no point ever the cloud provider could somehow decrypt this data, no matter the circumstances, like as a hard requirement. And of course, as a cloud provider, that is something, you know, general cloud providers that they cannot do, right? They can only make the service as good as possible, like as secure as possible, but there will be naturally be some limits because the cloud provider is in control in the end of the whole system, no matter how secure it is. And if you want to retain complete control, then there's only one way of doing this, and that is by encrypting data before you load it into any cloud service. And that can be quite painful if you want to do that in terms of maintenance, key rotation, key hygiene, lots of things you have to consider, and the responsibility, right, that comes with that. But in the end, to answer this question, encryption is the key, and for absolute complete control, and like on-premise control, you need to have the keys hosted on-premise or somewhere where only you have control over them, with policies that only you have control over outside of the cloud providers world. So again, not saying the cloud providers are not safe, but if you need that extra ownership, it's like on-premise type of ownership, then that's the only way of doing it. And there are only two more things I want to say to this when it comes to encryption, apart from the whole key management and the responsibility. There's also, especially when we talk about databases, if you use, what type of encryption are you using for what data and what use cases? because that really has an influence on how your users, like in an HR department, you cannot, like people that need some data quickly without thinking too much about the technical details of encryption. It's not part of their job. So you need to have this encryption to be transparent. It just has to work, and it should not influence the schema of your database. If somebody wants to put in a column that says salary, and that is a decimal column, that column should stay decimal even after encryption, and you should not need to change the schema of your database just because your encryption doesn't allow it. For example, if you're only using AES encryption, you would have to change the schema because AES only works with strings. And this is where format preserving, data type preserving encryption comes into play. And I think that is a crucial technique that needs to be applied when you load data into a data warehouse in order to preserve your schema and make working with data as easy and preserve the analytical value of the data as much as possible.
Makes sense. Makes sense.
Yes.
Alon, what do you think about that, and how do you make it even more secure?
Yes. So encrypting the data before it goes to cloud, right? And then also ensuring that the decryption happens outside of the cloud controls. So the cloud account admin can never run an external function and decrypt the data, or the cloud admin can never run a memory dump and see the data in the clear, right? These are all necessities of the regulated organizations worldwide, and this needs to be done in a transparent way, as Kevin mentioned, with the format preserving encryption.
Yeah.
So yeah, we can definitely sustain the type of the column, as well as much as possible be able to do that in a transparent way. So by having a centralized management of which columns need to be encrypted, both in the ingestion and in the consumption, by a single platform, it can both apply the encryption, apply the decryption with no manual effort, with full integration with the different ingestion utilities, such as whether this is Talent or Kafka, or whether this is Click Replicate or other type of ingestion platforms, as well as for the consuming side. And this platform also to maintain the key and apply the key rotation. Right? All of that is really something that more and more customers are looking to have a segregation of duties between the clouds and the data ownership. On top of that, the combination between encryption and ABAC, right? The understanding that this needs to be a joint play. You can look at ABAC as a compensating control for some purposes on some type of columns to the encryption. So it really is about providing security options, because encryption has pros and cons, dynamic masking as well. You have the compensating control of providing audit trails of who's doing what, when, and where, analyzing those audit trails to ensure the data is not breached, privilege are not being abused. Right? All of that comes to fruition, and hence addressing those challenges with multifacets, with monitoring, access control, encryption. All of that come to fruition in order to ensure the sustainability of the cloud platforms.
Yeah, I agree. The fact that maybe a good example is my blood pressure is not PII, is not a personally identifiable information. Therefore, it doesn't need to be encrypted. Nevertheless, I don't want anyone to get access to it. I want to have only, let's say, clinicians to have access to blood pressure information, right? So that's when you need both, right? So my PII, my name, my ID number, my email address, those have to be encrypted because it's PII. But my blood pressure might not be encrypted, but I still need to apply dynamic authorization on the same data. So it makes sense to do both. Right. The other thing that you mentioned is that the cloud provider should not have access to your data, and therefore you need to do the decryption outside of the same cloud. What I hear from customers, it's not just the cloud provider, because if the cloud provider can get access to your data, then the government of where that cloud provider resides have access to your data as well, because they can get a court order to get the data, or get the keys to get the data. So that's one of the problems as well. So it's also a legal issue, especially when you know geopolitical situation changes across the world. You want to make sure that the company is the only one that can actually make decisions about who gets access to their data, right? According to their situation, their needs. So that makes sense. So maybe the next one, Alon, you were talking about encryption. How do we make sure that encryption is secure with key rotation, and how do we do it without doing any kind of downtime for the system and the data?
Yeah, so the ability to do client-side decryption, as there's complete segregation between the cloud and your client, right? And the client can be your Power BI server, it can be your Tableau, it can be even different applications. The ability to completely segregate the decryption function from the cloud platform is important, because that's something that is ensures that the cloud admins that have ownership on the cloud platforms can never issue a decryption operation. From key rotation perspective, of course, encrypting the key encryption key can be done every hour with no implications. Doing the data encryption key, that's of course a bit more tricky. And there, one of the options that we provide to our customers is the ability to clone the table itself, apply an encryption and decryption, right? Because you need to decrypt the original column with the old key, encrypt it with the new key, and this is an operation that can take hours based on the size of the table, right? Or even more. So doing that to a clone table, and at the end of the process, simply switching those tables will allow the transition, the data encryption key transition, with zero effort and with minimal downtime as possible.
With applied change, something called applied change. So the delta, right? The delta of what was updated during the time you were encrypting with the new key, right? And that makes sense. Kevin, how does it work natively, the key rotation?
Yeah, just also touching on the table thing, I think you're using zero copy cloning for
Zero copy clone, right?
Yeah, so that's something that Snowflake provides, is that you can copy a table without copying the data. It's just a metadata operation inside of Snowflake.
Right.
So you have another table that's just the table is just metadata that points to the same files, and then you apply your operations on the copy. And then, of course, you have to take care of the delta that's in between. That's what SecuPi does. So it's really a great best of both worlds.
Yeah, zero copy, that's like kind of a famous advantage of Snowflake.
Yeah, and this is really good. And then you can key rotate extremely fast without downtime.
Exactly.
And then what you just said, the native ability, yeah, Snowflake on the storage layer, as I said before, we also, of course, encrypt data. So right now what we're discussing is the extra column level encryption. The Snowflake encryption works on that we have also a key hierarchy of different keys that protect each other, that wrap each other, and all of these keys are rotated every 30 days. And then the keys that actually encrypt the data of any customer are generated when needed. They're not stored anywhere.
Yeah.
So I guess what I'm saying, not to talk too much about Snowflake, what I'm just saying is, if you're looking, I guess the takeaway is, if you're looking for what you need when you look into the cloud and your data, is two things, right? Once the cloud provider such as Snowflake needs to have a solid encryption standard itself, And if you want the absolute on-premise control over your data, you absolutely need, for example, SecuPi, right? Then you have the ability to also decrypt and encrypt with another layer on top of it in a transparent and easy manner, and do this key rotation and key management, and the attributes and all the stuff you take away, make it easy for customers to have absolute control over their data. So this is, I think, a really good thing to consider when you're dealing with PII data, especially if, what you also do, right, is this policy enforcement points. You can enforce decryption down to the city level, office level, right? Only a specific office or country, city, or specific office can decrypt data because the policy enforcement point is sitting there and only decrypted for these people that are there. So these are really, I think, great points in terms of encryption.
Yeah, makes sense. So we talked about, multiple aspects of security.
By the way, there's a question. Maybe we can answer it about the ability to connect which KMSs HSM are supported.
Yes, that's a question from the audience.
Yeah.
Go ahead, Alon. Do you want to answer?
Yeah, so
what
we
is
support
supported?
any KMS, any HSM, and also SecuPi comes with our own FIPS compliant key store, right? So everything optional. So for example, if you have your cloud data store is on AWS and you wish to use an Azure KMS, it's possible. Or you want to use your HSM on-premise, possible. Or you just want to use SecuPi key store as well. So everything is possible and supported.
Or even a software-based KMS that can run on-prem, right? It doesn't have to be HSM, but yeah, it's a standard base. The good thing about KMSs and HSMs, they've been around for a long time, so there are standards. So it's easy to connect to all of them. That makes sense.
Yeah.
And I'm assuming it's very similar on the Snowflake side, right? In terms of managing keys with external KMSs and HSMs.
When you bring your own key, we only support Azure Key Vault, AWS KMS, and GCP KMS today. And it must be in the same region as the Snowflake account.
Of course.
Makes sense.
Of course.
Okay, so we talked a little bit about the encryption and dynamic authorization. If we're talking about compliance and specifically privacy compliance, what other aspects? I'm guessing, for example, right to be forgotten and things like that. How can that be applied in a cloud environment?
Yeah. So this is something that we saw in the beginning in Europe, in the notable customer that we serve, but in the last 2 years have been expanded to the US. As well as in ABAC, also in Asia Pacific, PDPA, PDPB are also imposing the right to be forgotten or the right of erasure. What we've been able to do is to build a module that would automatically be polling the consent, for example, from OneTrust. And then through the catalogs, whether this is our catalogs or whether this is Elation or whether this is Colibra or other data catalogs, being able to apply the deletion on multiple data stores, both hard deletion or soft deletion, right? Why do we need hard deletion and soft deletion? Hard deletion, everybody understands, right? It's just going to the database and deleting the row of the customer. But how do you do that on immutable data stores? How do you do it in mainframes, right? Who will even allow you to do that if you have an Oracle database with 20,000 tables, where the email is the primary key, right? The unique index, right? So how do you do that if you want to delete an email? And that's why we resort to different options. Either the logical deletion, few a few large insurance customers are using SecuPi to apply logical deletion, which means basically to filter out customers who asked to be forgotten from the results that return to the end user. And this is serving the purpose of the law. So being able to put the logical deletion on applications without actually going and doing the hard deletion is a viable option that has been approved by CNIL and Garante and the different regulators that are serving the purpose of the law, as well as combining that with hard deletion in places where it can be done. For example, in analytics environment, deletion is easier than on operational data stores. So we will provide this best of breed where there's an ability to delete or at least mask the sensitive fields. We will be doing that. And in places where this is impossible, in those cases, we will apply the logical deletion to provide an end-to-end deletion compliancy to the organization.
Makes sense. I think I also, what I heard from customers is that they like the operational efficiency of gradual removal, right? So what you said about soft deletion means we are not touching the database. The database stays intact. We are not changing anything. It can be encrypted. It can be not encrypted. We don't care. It's all about how we are not displaying customers that wanted to be forgotten. Then there is a middle phase where we can say, okay, before we delete something, we're going to hard mask it, right? So for example, we can leave the main key, the primary key of the customer, but everything else we can put an X or nullify it, zero it, so we can change the data there. So the record stays, but the data changes, right? So that's kind of a second phase where you test it and you see, I'm not deleting it yet, but I'm changing the data. Let's see if something breaks, right? And then once that works, you then say, okay, now that I see no one complained, the systems are still working, now we're going to delete the record for the user. So you have a kind of a gradual implementation of deletion while still complying with the regulation, right? Because even when you do soft deletion, you're not touching the data, but no one can see that user anymore. So you actually comply with the regulation. So that's operationally, customers like it because they don't want to have big changes in IT. And sometimes those can be mistakes, right? What happens if someone hacked to your system and decided that all customers wants to be forgotten? You don't want to delete all of your customers because of a hack or a mistake or anything like that. So you want to have a gradual approach to something sensitive like that, right? Kevin, what do you think?
Yeah, definitely. Also, when you have a legal hold, for example, right, you have an employee that left the company and now asks for his data to be deleted. Maybe you cannot delete it because there's some time that you need to keep the employee data around because of legislative, some laws. Or there's maybe even a legal action pending that requires to keep some data on the record. And only when legal clears that data for hard deletion, then the data should be deleted with a legal clearance. So it's definitely best practice to do it like this. Yeah,
makes sense. That also sounds like a dynamic authorization, right? Because on one hand, you have the customer saying, I want this to be deleted. Then you have IT saying, well, maybe we'll do something initially. And at the end, legal needs to approve it to say, okay, now we don't have any hold. So it's approved for deletion. So it's also kind of dynamic authorization of deletion, right? So
you can look at the right to be forgotten as the easy path of the regulators to ask large organizations to apply access on a need-to-know basis. Because for sure, nobody needs access to those old customers, right? So that's like from the edge going from the regulator perspective, asking to have this access on a need-to-know basis in the places where this is really deterministic, right? So, but it's also this notion of dynamic authorization to the customers based on their deletion state.
Yeah. So that's good. Now we have a question from the audience, and they talk about, can we review data classification? So is there a kind of out-of-the-box data classification, custom classifications for structured data, unstructured data? So they're asking about, how do you integrate between classifications and policies?
Yeah, we have the ability to integrate with any type of data catalog, right? Either import that or integrate with it, like we have the integration with different catalogs such as Deletion, Colibra, as well as Big AD, as well as Purview, right? Also, you can use the Snowflake tags, right? And classification, the internal Snowflake abilities to do that, as well as the even homegrown, right? The ability to add classifications into the product or use the SecuPi classification engine as well. So all of that come to fruition in order to tag and to classify the data to be able to apply those coarse-grained access controls, and from there continue to more fine-grained controls on the row or even on the cell level.
Makes sense.
Yeah, so I think that both SecuPi and Snowflake can apply policies based on tags and classification, and there's also different abilities to classify data either manually or automatically detecting it. And what you just said, Alan, like the ability of both SecuPi and Snowflake partners, and SecuPi itself has a classification engine that can tag and classify data and then apply policies on them. So with structured data, I think that's easy to that's clear now. Unstructured data, it just sits. It's like byte data that sits in, at least in a Snowflake where it sits in a column. So we would just tag this as that column. But to detect what's inside the bits and bytes, I think that's a bit of a challenge. So at least in the Snowflake world, there will need to be manual detect, or the classification engine just says, okay, here's a byte, a blob or something in the column, tag this and classify, and then SecuPi policies and or Snowflake policies can apply to that tag or classification.
Yeah, makes sense. So that takes me to the last question, because I think this audience question is very relevant to the last one, which is, what's the evolution? What will happen to security and privacy within cloud environments or hybrid environments, right? Because one of the things here is that, okay, you have unstructured data, you have structured data, those sometimes are being treated separately, on-prem, sometimes treated separately than the cloud. One database is treated separately than another database. So right now we have kind of a fragmented way. If you look at one organization needing to do everything, it's a little bit fragmented. So how do you guys see the evolution of security controls and compliance governance evolving in the future?
So just
go ahead.
More, right? More and more complexities, more regulations, more data cross-border controls, more clouds, right? More data platforms out there. So it's just going to be a continuous chase, in order to apply the data controls, both from the data source perspective as well as the target. Right? We talked about client-side encryption, so it's just going to be more and more complicated. Native cloud applications are going to be massively used. So where's the context? Where are the attributes? Where should we put the enforcement point? At the source, at the endpoint, right, and everything in between. So it's just going to be a crazy technology chase to follow the data wherever it lies, to provide the enforcement points to the right place where we can apply this dynamic authorization, the encryption, the monitoring, etc.
Makes sense.
I agree. I think it's a great revival of of all things encryption. So different countries make new legislations in isolation and just say, this is a complicated world, but here where we control our laws, we'll just decide that our citizens or our data must be stored in our country, and if somebody else has it, it must be somehow inaccessible, or there must be a way to make it inaccessible if you want to others, but we want to keep access to it all the time. And then you have, so this is the legal world, and then there's the compliance world that is where the industry and the consultants decide on what is best practice and issue certifications on that. And then this goes hand in hand with the legal world. And they're also always finding new ways of making things more complicated. I think in the end, all of this complexity will lead to a simple answer: is how good is your encryption, and how well can you manage it, and how much control do you have over it? So yeah, the world will be more complicated, and encryption will have this great revival. I think that there will be more focus on things like that.
Yeah, I agree. I think the future will go into this holistic approach where everything will be easy to manage from one central location. That's on one hand. On the other hand, everything will be very close to one another, right? So actually, when I was at the Snowflake conference, I heard the same thing from Snowflake. You're moving more and more applications into the Snowflake cloud to get as closer to the data as possible, right? And if I look at it from a security point of view, that's making it a lot easier, because if you encrypt there, it will be easy to open it there and apply those kind of policies. So I think in general, it's going to be easier to do cross-platform, cross-cloud hybrid approaches to manage security and compliance. That's one. And two, it will also go back to basics. It's always user identity going to data. So everything is going to be data-centric and identity-centric together, in order to make sure that we know who the person is, where they're coming from, what data they're trying to get access to, and apply the CIA, the confidentiality, integrity, and availability aspects of getting access to that data.
Yeah, what you're saying. Sorry, go ahead.
No, that's it. Yeah.
I think we left out something really major, and you actually kind of touched on it. Is you're saying person, right? But I think there's also another major trend that I almost forgot talking about, is the whole large language models and AI. That trend. So right now in Snowflake, that you can have run a large language model inside of a Snowflake now, like a Docker container running inside basically your warehouse, accessing your data directly where it is. But what does that mean for security and compliance, right? And then you have to just think about this. And that goes back to basics again, right? Once is either you don't train your model with sensitive data in the first place, end of story, right? And you have to enforce this. Again, where comes the data from? Is it encrypted? You cannot train your model with it, right? And then if you do train your model with sensitive data, you should not train it. But that's just my opinion, by the way, not a Snowflake opinion, my personal opinion, that you need to train your model maybe tokenized, right? Or like PRI data, if it is somehow in your model, and you go back into formal preserving encryption, tokenization, once again, will play a role there. I think if you need PRI data in a model, for example, patient data tokenized, you can say, tell me, you talk to your data, right? Instead of doing SQL, you chat to your chatbot, and it says, in our hospital, the patient age is on average this and this, without doing SQL. This is super great, but the data that's behind this, and the PRI, if there is any PRI data, you have the age, but if there are any names, they should have been tokenized. Like, who's the oldest patient that we have? It gives out a name, but that's not the real name. And only the ones that have access to untokenize that name from that chatbot should then be able to go behind this, right? Or a last thing that could happen is that you tell the model to access PRA data dynamically via an API call, and then you're subject again to SecuPi and Snowflake policies. You are accessing via API through a policy enforcement point or through Snowflake policies, and ABAC and ABAC, and your model will then try to fetch this data, but is governed, that data that's dynamically fetched is governed properly. I think these questions is something that will come up also in this, and I think it will once again go back to basics and all the things we discussed today, and how even in the large language model, how to safeguard data. Alan, do you have maybe also something on it?
Yeah, fully aligned. You know, the processing of data, how to identify it but still keep it valuable, right? This is the two opposite, right? Yes, and that's why different options are really required. So tokenization, encryption to the really restricted PII, but then fine-grained access controls and dynamic authorization, and simple auditing and monitoring to ensure that the access to data is not abused, right?
Right.
All of these need to come to fruition, especially when new challenges are there, such as, you know, providing more ML and AI to the data themselves.
Well, I can't believe I'm saying that, but we're over. It's about an hour. It was a very engaging conversation. Didn't feel like an hour, but it went by very fast. So I want to thank you, Kevin. I want to thank you, Alon, for a very engaging conversation and very interesting. And I'm sure we'll continue and do other webinars with interesting chats.
Thank you.
So thanks a lot, everyone. Take care.
Kevin.
Thanks, everyone, for joining. And hopefully you enjoyed the webinar. Take care, everyone.
Bye.
Bye.